Okay, we're going to be looking at some more linear programming problems. So this one says, tax firm Knight and Knight needs to determine the clientele it will seek for the upcoming tax season. Firm provides two services, a basic tax return and an in-depth tax return. Firm charges $50 for basic and $150 for an in-depth. Find the number of basic and in-depth returns they should provide to maximize revenue. And so looking at it, you say, well, if you make 3 times as much for the in-depth, then why not just focus on the in-depth totally, or do as many of those as you can so that you make the most money there because you're making 3 times as much. But it's not always the case. That's why we have the constraints and why we use those to see what's truly going to be the best depending on those constraints that we have. So first, we're going to write an equation for the total amount of revenue that they could make. So for every basic return, they're making $50. So we'll do 50 times X, because that's whatever the number of basic returns is that we have, plus 150 times Y, because that'll be the number of those in-depth returns that we have. Then we get into our constraints. So basic return requires half an hour of preparation time, in-depth requires 2 hours of prep time, and they've got a total of 700 man-hours prep time available per week. So setting up in the same way, 0.5x plus 2 times y, and that should be less than or equal to 700. So we get kind of an idea here of, okay, well, you make 3 times the money from the in-depth return, but it also takes 4 times as long for the preparation. And then looking at the other constraint that we have, basic return requires 0.6 hours review time, in-depth requires 1.2 hours of review time, and they have 510 hours of review time available per week. So it's going to be 0.6x plus 1.2y has to be less than or equal to 510. Okay, then our last constraint down here, office must provide at least 100 of each type of return. And so when we just have one number that's the same for both of them, then this is going to be one of those one variable inequalities. So x has to be greater than or equal to 100, and y also has to be greater than or equal to 100. So we'll be able to graph those pretty easily, but let's get some more information on these other two so that we can graph them quickly and easily. So I'm going to find my x and y intercept because those are also have the potential to be one of my corners. So for x and y, when y is 0, then if I make y 0, that's going to be 0.5x equals 700. So if I divide 700 by 0.5, or if I multiply both by 2, I end up getting x is equal to 1,400. And same thing, when x is 0, I get 2y is equal to 700. I'll cut 700 in half, and I should get y is equal to 350. So the x-intercept was 1,400. Y-intercept is 350. Next I've got same thing here for 0.6 and 1.2. So if y was 0 We'd say 0.6x is equal to 510. So dividing that out, or so taking 510, you divide it by 0.6, we should get 850. Then do the same thing for 1.2. And we think, well, if this is double that, then what's equal to on the other side should be basically be half as much. So 425. So x-intercept would be 850. Y-intercept 425. And we could write those as ordered pairs if we need to, but my guess is that we've done this enough recently here that we can do that without having to write all that down. So, next thing we're going to do is take and put these on our graph. So, on my graph here, I've labeled these basic returns times 100 and in-depth returns times 100. That way, I'm not having to label 100, 200, 300, so on and so forth. And it gives me just a little more space to work. So, looking at my first one, I had an x-intercept of 1,400, should be right there, and a y-intercept of 350. And so, notice I've spaced these out to where each line is 50. That just gives me a place to hit where it's pretty close on right there. So that line's going to be right there. Then for my next one, I have 850 as my x-intercept, and my y-intercept was 425. Got that one there. Now let's not forget about our 2 at the bottom. I have x needs to be greater than or equal to 100, and y needs to be greater than or equal to 100. So we'll graph those out here. Try to thicken that line a little bit so we make sure we see it. And there's my y. Try to go off the line a little bit just so it ends up showing up real well. Okay, then for our shaded area, we could do our zero test, but I know it's greater than both of the 100, so going this way, and then less than both of these, so should be going down in this area. So I'll end up with this similar shape that we've had before, just right there. Okay, and again, we are looking for we're looking for maximums. So this point down here is one of the corners of 100, 100. Probably not going to use that one, but we've got 3 other corners, and so difference now is I have 3 corners that I don't necessarily know everything for. So let's start out, and I'm going to label these corners as A, B, and C. So it'll be corner A, B, and then corner C right here. And let's do a little bit of solving to see if we can figure out what those corners are. So, first one is on my line of 0.5x plus 2y equals 700. I know the x value is 100 because it meets that line here. So if I put 0.5 times 100, then we're just going to solve for y. plus 2y equals 700. So half of 100 would be 50. Then when I subtract 50 out from both sides, I get 2y is equal to 650. And when I divide both of those, that should be y equals 325. So my x value would be 100, and my y value is 325. Again, that's just substituting in because I know this line here that comes up to meet this is 100. So that gives me my x value of 100 and y value 325. Then for the c down here, kind of the same thing, just using the different formula, the one with 0.6 and 1.2. So I know the y value is 100 on this one. So 0.6x plus 1.2y, or 1.2 times 100, equals 510. And this is going to be, that was for line A, this is, or point A, this will be point C. So that gives me 120 plus 0.6x equals 510. When I subtract that out, it gives me 390 equals 0.6x. And when we work that out, it ends up as x equals 650. So that means this point would be 650, and then the y value is 100. And the last one, that pesky point B. Now in this one, I don't know either of the values, so I'm going to take and substitute in, or do either substitution or elimination, so I can figure out what that point is. Okay, so I will continue that in the next video, and we will find our maximum for this.